Let us understand how the machine learning technologies got evolved. Within machine learning, we need to apply some XYZ algorithm. As a developer, we will not be in a position to develop the specific machine learning algorithm and recode them every time. So a number of libraries got evolved. One such library is scikit-learn. And this uses the Python as a language where it has a number of algorithms, and this is currently being used predominantly in the analytics world for machine learning. And this has implementation for almost every machine learning algorithm that we have now. And when this is being used predominantly using the Python language, it can do the processing or analysis using a single computer system. We can make it to work with multiple computer system as well, but when we have the data volume as very huge, a single system, or when we are doing it with the parallel computing, we need a mechanism which can do the coordination by itself. That's where the frameworks or libraries that got evolved, like Mahout, where it is going to do the machine learning in a very scalable way, that is in a horizontal scalable way. While doing the machine learning and while executing any of the algorithm, I may have to analyze the data very recursively. In the sense, I may have to read the same data again and again, and I might be trying to generate the result, like a recursive calculation. I'll read the data, generate the result, write the data back, and then again read the data. I'll write the data back. Say 10 or 20 iterations, still I get an accurate result as my expectation. And generally the hard disk are very IO intensive, and I cannot read the data from the hard disk every time. So what I prefer to do, I will prefer to cache the data. Using the RAM is more optimal one, where I'll read the data, load it into the RAM, that is memory. So as a one-time activity, I can load the data, or I can have that particular data within the memory itself, and I'll be doing the recursive calculation from the memory. And also sometimes I may have to refer to the data more frequently again and again. For example, to do the recommendation engine, I may have the model already generated. If I have the model in the hard disk, and if I'm going to use the model to do the recommendation, I might have to read this model every time. If I know I am going to use the model more frequently, what I can do, I can read the model and store it within the memory. If I have it within the memory, I can refer to this model more faster way. That is, I'm going to get a better IO, and I'll be in a position to get the prediction much faster. So RAM, it will satisfy the requirement of caching the data and providing a very high IO. But horizontal scalability is going to be a question. In case if I wanted to store very huge amount of data, say I want to store 500 GB of data into the memory and do the analysis, a single system may not be sufficient enough. I may need to share the memory of multiple systems. Let us say I do have these 4 systems. For understanding purpose, let's take, I have these 4 systems, and each system having, say, 150 GB of RAM. So together, if all the systems can be virtualized or can be brought as a single entity, I will be having 600 GB for my disposal. And if I have an ability to have the data divided across multiple systems, that is, assume I am going to do the processing of, say, 300 GB of data. Or let's say I'm going to do processing of 200 MB data. What Hadoop can do by default, it can divide that into 2 blocks. As per the default block criteria, it will divide that into 128 and 72. If this block is divided into multiple systems as per the HDFS algorithm, and 2 different systems can do the processing. If I have the ability to consolidate the data available within the RAM of 2 different systems and consider that as a single entity, assume these 2 data together, I'll be considering it as a single entity. I can do any processing or transformation against this data. Assume I'm going to filter all the error records. I'll get the data processed parallelly on both the blocks, and both the blocks would get the result. The result might be like not be 128 MB in this case. I might have a smaller piece of data. Let's say here I might have only like 8 MB of data, and here I might get only like say 2 MB of data. But eventually I am able to distribute the data within the memory of different systems and consider that as a single entity. That's where Apache Spark framework comes into picture. And Apache Spark, we call it as distributed in-memory computing, which is going to facilitate the data available within the memory of a distributed system and consider that as a single entity and do the processing, it has a number of different libraries on top of it, and it supports multiple languages. And within the machine learning distributed computing world, Apache Spark is predominantly being used next to Mahout.